The world is on the cusp of a clean energy revolution. Batteries are essential to this transition. They power our electric cars and store energy from solar panels and wind turbines. This shift away from fossil fuels is crucial to combat climate change. However, the production of these batteries has environmental and social costs. Demand for batteries is skyrocketing, driven by renewable energy needs. Electric vehicles are also fueling this demand. This surge presents immediate challenges. The extraction and processing of raw materials have significant impacts. We must address these impacts for a sustainable energy future. The transition to a low-carbon economy requires more batteries. This demand cannot be met without considering the consequences. Mining for essential minerals can devastate ecosystems. The processing of these minerals is energy-intensive and polluting. We must look at the entire battery life cycle. Mitigating negative consequences is key to a sustainable energy transition. Battery mineral extraction often occurs in countries with lax environmental regulations. This leads to water contamination, deforestation, and soil degradation. Indigenous communities often bear the brunt. Their land is targeted, leading to displacement and cultural disruption. These practices raise serious ethical concerns. Processing requires huge amounts of energy and water. The chemicals used can be toxic. They pose risks to human health and the environment. Workers often lack adequate protection. Addressing these issues is crucial for a just transition to clean energy. Much of the world's cobalt comes from the Democratic Republic of Congo. Artisanal mining often involves dangerous conditions and child labor. These practices are linked to human rights abuses. Consumers and manufacturers demand ethical sourcing of these minerals. China has emerged as the dominant player in the global battery supply chain. It controls a significant portion of lithium, cobalt, and nickel refining. China also manufactures a large share of the world's batteries. This dominance gives China considerable leverage in the global energy transition. It also raises concerns about environmental and labor standards. While China has made strides in greening its manufacturing sector, challenges remain. The country's reliance on coal for energy production is a major contributor to air pollution. This pollution is linked to respiratory problems and other health issues. The environmental and social costs of China's battery production raise concerns about the sustainability of the industry. The concentration of battery production in China also raises geopolitical concerns. Countries are increasingly wary of relying on a single source for such a critical technology. This dependence could create vulnerabilities in the global supply chain. Diversifying the battery supply chain is crucial for ensuring energy security and promoting fair competition. Section 4. Greening the battery, a multifaceted challenge. There are several promising solutions to mitigate the environmental and social impacts of battery production. One approach is to develop batteries that use less environmentally damaging materials. Researchers are exploring alternative materials like sodium, magnesium, and zinc. These materials are more abundant and less toxic than lithium, cobalt, and nickel. Another solution is to improve the recycling and reuse of battery materials. Currently, only a small percentage of lithium-ion batteries are recycled. This is due in part to the complexity of the recycling process. However, advancements in recycling technologies are making it easier and more cost-effective to recover valuable materials from used batteries. Transitioning to renewable energy sources for mining and processing is essential. Using solar and wind power can significantly reduce the carbon footprint of battery production. Implementing stricter environmental regulations and monitoring throughout the supply chain is also crucial. This includes holding companies accountable for their environmental and social practices. Section 5. Towards a sustainable energy future. The transition to a clean energy future hinges on our ability to address the challenges of battery production. We cannot ignore the environmental and social costs associated with this technology. A sustainable energy transition requires a holistic approach that considers the entire life cycle of batteries. This includes responsible sourcing, clean manufacturing, and robust recycling programs. Consumers have a role to play in driving demand for sustainable batteries. By choosing products from companies committed to ethical sourcing and sustainable practices, we can incentivize positive change. Governments can also play a role by implementing policies that promote responsible battery production and recycling. Investing in research and development of new battery technologies is also crucial. The battery boom presents both an opportunity and a challenge. It offers a path to a cleaner energy future but requires careful consideration of its impacts. By addressing the environmental and social costs of battery production, we can ensure that the clean energy transition is truly sustainable and equitable for all.